Hello friends, in this class we are going to learn on continuation of how to draw EHT towers. In previous class we have seen what is the importance of supporting materials in transmission and distribution system, and we have seen that a transmission tower is a tall structure, usually a steel lattice tower used to support and overhead power lines. And also we have seen different shapes of towers, and their shape and height and mechanical strength depend on stresses to which they are exposed to the atmosphere conditions. And also how to draw pylon tower and few EHT steel towers in free hand drawing with given dimensions. In this lesson we will learn clearly how to draw 132 kV single circuit and double circuit, and also 220 kV single circuit and double circuit with given standard dimensions, step by step with animations. Let us start our class, dear students. Line, you take it straight line. Okay, then you take the what is the foot area. So based on the area you take it, and so from this length, so assume some suitable length here and draw the cross lines here. Okay, now take the different portions. So I can take it this different portions and cross it as per your requirement. Enough. Sometimes if required you can show this is also. Okay, so different shapes you can create it. And next you take the another length of this line here and take the end top position. Now you take the one, so from this place to this place you take it. So you can take the this cross arm and you take the some length here and cross it. Now you take the another length here, take this one. So because they will give the what is the distance from this one, you will give. Now you will give the all distances. Okay, just you write it. This is the another face. Next you are going to get it so these are the structure, dear students. Okay, so here everything is show the some insulators. So this is the basic thing. Okay, so this is the one single circuit tower, dear students. And double circuits, so as usually you write it. Take the one line. Okay, once again you can see it. Whatever the base foot is given, and you take the approximately, for example 4 meters is given, you take the here 1.5, you can take this length and join these two lines here. Okay, then you can create, so as per your requirement. So here you can write it here. This is a mechanical support. Okay, so you can show just like here. All are the just mechanical supports. Okay, so this one. Now take the whatever the length is given here. Okay, take this one length up to this one here, and suppose you require the double structure is required. For example, you require the another face, for example OR face is required, then write it. So take the from this length, what is the distance, and what is the distance, you take it and join these two lengths. Okay, then you just remember this and just mechanical step. This is one face. After this, you are going to create another Y face. So you can take the Y face, and from this length you can create another length, from create another length and write. So you have the drop down, don't worry. Okay, next you are going to RYB, another face. So blue you are going to write. Next, here you give the tab, this one, and so this is a OR face, Y face. And finally, so you are going to select the end supporting part. Okay, so that is the end ground wire purpose we are going to use it. So here height length, so we are going to get this one. Okay, so this is a lengths, different lengths. Okay, so this is a one tower, you can see, dear students, this is a double structure, DOU, double circuit, because OR face, Y face, B face, this is a one circuit, here is another circuit, whereas in this case single circuit. So because here OR face, the Y face and B face. Okay, your aim is to draw this simple only. You will give the dimensions, what is the dimension, what is the height, what is this height, what is this height, what is this height, what is the length, everything will give, but you have to prepare neatly these diagrams. So our aim is to draw 132 kV single circuit, and double circuit. Okay, so single circuit and double circuit at the same time. So 220 kV also single circuit and double circuit. Okay, in this class we are going to draw only these four figures, dear students. How we are going to draw that one, what is the physical, the structure presence in real field, I can show you. Okay, so there is a one animation I created for you. So every structure, how to start first line, second line, third line, fourth line. Okay, complete, just like similarly what I have seen, I have drawn here, you take similar way. Okay, so dear students, let us see the animation figure. Okay, it's very easy, dear students. Dear students, what is this one? It is a 132 kV steel tower single circuit. You can observe this type of the towers nearby our villages or mandals. Here you can see this is a one phases, you can use here the OR face, Y face and B face. These are all fields you can see. So how this is the structure, 130 kV structure, and you can see the steel towers. Okay, so I am going to draw this 130 kV steel tower. Okay, that purpose I required some dimensions also I have required. What are the dimensions I need here? So that means your dimensions, based on the dimensions you are going to draw it. Okay, so first of all, so here you can draw it, this length, you take the length, so you take this length here, this texture I am going to draw it. Okay, so what to do here, you will give the length. So generally this 132 kV tower length is of 4 meters you will give. Then total height of my tower will give, so that is a line, I can write it, so nearly, so 25.53 meters total length. Okay, now so structure from this length to this length, so what is the distance? So I am going to write it nearly 17 meters. That means 17 meters is the ground clearance required for 132 kV line. Okay, so here now this is over. From this place to now I am going to write it. So another structure, so this one distance I require this distance. So that distance may be nearly 3.1 meter. So face to face I require the 3.1 meters required for the two cross arms. Now in this case I am going to draw it, so this end and this length, so I am going to distance from this two, so nearly, so 2.6 meters distance. So these all dimensions you have to remember. So you will not give the in exam, you have to remember in 132 kV what is the base length 4 meters, what is the total height 25.3 meters, what is the first phase, so from ground to here, so 17 meters, and from this phase to this phase what is the distance 3.1 meters. Okay, now this phase to this 2.6 meters. So height we found it. Now at the same time I am going to find that what is the length from this place to this place. So that is because it is a ground, this is a live, it is act as a capacitor. So what is the distance we have to maintain? This is nearly, so 3.9 meters gap from center to here, so 3.9 meters. Okay, so that is the distance. Whereas in second phase I am going to increase this length here. So in the 130 kV single circuit, that is nearly 4.1 meters, dear students. Here 3.9 meters, whereas in the B phase, Y phase, so distance is the from structure to this string, the 4.1 meters. Now coming to the last one, here the length, this is maybe only 3.2 meters. Okay, so that means all dimensions are not equal. You have to remember that one. This is a 3.9, this is a 4.1, this is a 3.2. Okay, so these are the dimensions, dear students, and from this place to this one or top ground wire, so that is nearly 2.6. You have to make the 2.6. Okay, 2.6. This distance. So these are the structures, dear students. Okay, so you have to remember this all things. Okay, so don't bother. So one time or two times if you are drawn in drawing sheets, you are going to learn these dimensions. You remember these dimensions. What is the base, this one. Okay, so let us draw this one in once again in figure. This is a ground. Let us take this is a ground. Okay, now what is the line? Okay, take the one line, that is a nearly 25.3 meters based on the, you take the one dotted line, that is equal to, what is the distance? 25.3 meters. Okay, now based on this one, so what is the foot length? Here 4 meters foot. So from here to here 2 meters, here to here 2 meters. Point it. Now up to 17 meters is given, the 17 meters. You want to give the 17 meters. Now here I want to place here 4 meters now. Instead of 4 meters, you take the total length is equal to nearly 2 meters, you can take it, or less than 2 meters, or maybe, okay, 2 meters you can take here, 1 meter here, 1 meter here. Take the appropriate based on your sheet adjustment, and draw a line here, draw another line here. Okay, so this is I taken the 2 meters total length, I taken the 4 meters here. Okay, so appropriately you take the mechanical strength here as per your convenient. Okay, I taken here one structure, I taken the another structure here. Okay, so based on this one I can write it. So here structure, different structure, you can show the different structures. This is the one. Next, after that I am going to get it, what is the length? So 3.1 meters. From here I am going to place it, first one. No? So from here I am going to write it. So what is the length here? Sorry. So instead of here I am going to write it this length. What is the length? 3.9. Okay, this is a 3.9 meters. From center to 3.9 you take it and take the appropriate place. So it can take the 1 meter at least. So you take the distance here. Okay, so nearly you can take the 1 meter and length, join this one. Okay, so now I draw it length. Okay, so now it join it. This is a distance from the here. Okay, 3.9 meters from this place. Now this two I am going to write it nearly 3.1 meters. 3.1 meters. So I can extend this length. Okay, so distance. Now, so here I am going to extend the length, that is equal 3.1 meter. Okay, this place to this place 3.1 meter. You can create anything. And from center to I am going to, what is done here, 4.1 meter. So take it the 4.1 meter here. Next, take the 1 meter length here and drop it. And take this one. Okay, another phase is completed. So here 3.1 meter length from this one. Next, and that is equal length, the 2.6 you can from this one. Okay, you are going to increase from this distance. What is that? 2.6 meters. So here from this one to this one 2.6 meters. Now length you can take from this length to this length, that is equal 3.2 meters, and take some appropriate place here, extend here. Okay, so this is remove this also. Now this length also we found it. So here you can join the mechanical section. Now afterwards, so you are going to create from this place to and top of this one, that is equal to the 2.6 meters. Okay, so then just join these lines. So dear students, so this is a structure, you can see structure, this one. Okay, how this tower is designed, we taken this length is equal 4 meters. Okay, you can take the color, this one. Okay, what is the length? This is equal to 4 meters. That's why 2 meters, 2 meters I taken the length. So nearly the total length up to past this one. So up to this one I taken the length 17 meters. Okay, after that I am going to here. So from this place to this place I taken the, what is the distance? That is a 3.1 meters. And this place to this place I taken, the distance is the 2.6 meters. And this place to this place I taken the distance 2.6 meters. So total height I divided. Okay, after that, so from this place to this place I taken the 3.9 meters, and so approximately proportionally I taken the 1 meter height from this one and join this cross arms. So this is a mechanical cross arm. Okay, so this is for the orifice. After that, so distance I know that, so from this place to this place I taken the 3.1 meters, and from this place to this place I taken the 4.1 meter, and approximately I take the 1 meter here and take the cross arms. So just I connected here. Next, after this place to this place I taken the 2.6, and from this place to this place 3.2 meters and taken the cross arms. Okay, then you indicate the some string here. So this is total 132 kV single circuit. Okay, 130 kV single circuit resistance. So based on the dimensions, first you should know so where to start and where to end. That is a very easy. You have the dropped, you have the pencil. You can easily draw it. So this draw such a way that you have to complete the remaining all figures. For easy understanding purpose, I have created one animation for you. Okay, so based on the dimensions, you draw it. Okay, let us say that real figure. This is our drawing. Okay, so we have to draw drawing. So for clarity purpose, I have drawn the R face, Y face, and B face different colors for easy understanding distance. Don't confuse. But you have to remember that what is the distance from these two, what is the distance from these two, and what is the distance from these two, and what is the distance from these two. At the same time, what is the distance from here, what is the distance from here, what is the distance from there. This is enough. After that, so remaining these textures you may create as you like. Okay, let us see. Now first we take the one ground line. You can see this is a one ground wire. Okay, then you take the, what is the height? It is a nearly 25.3 meters height. Now you take the base, that is the 4 meters. So this length is equal to nearly 4 meters. After that, so give the all structures. So you can see this is the structures up to this one. What is the length here? So I taken from this place to this place. It is from here 2 meters, 2 meters, and this height is the, okay. So what is the height? Height is the nearly I taken. So up to this one I taken a single 17 meters. Okay, now after that I extended the further line. Okay, so this total section at a time I can extend it. That means total 25.3 meters I extended this line. Now from the bottom to 17 meters I placed one cross arm or face. Now in this case I taken, this is what is the length. So this distance from this 17 meters, and this distance is the 3.9 meters. Okay, so this one phase is completed. Next, another phase. So I taken the here another phase. In this case, what is happened? So here up to this is equal to 17 meters. Okay, now this place to and this place I am going to give the connection. What is that is a 3.1 meters, 3.1 meter. Next, I want the length from this place to this. What is the length? 4.1 meter. So this center to this one 4.1 meters, and this to this length. What is this length? That is equal 3.1 meter. Okay, I am going to get the Y phase. Now after that, another remaining phase is a B phase. Okay, so what is that B phase? From this place to from this height to this height, 2.6 meters. Now what is the distance here? The distance is equal 3.2 meters. Enough. So up to this is 17 meters, and from this is equal to 3.1 meter, and here 2.6 meters, and this is equal 2.6 meters. So total height is enough. From this place to this place, that is equal 3.9, and this place to this place, so that is equal 4.1 meters, and this is equal 3.0 meters. This is enough. Okay, so dear students, such a way that you have to draw it. Okay, draw simple and place some insulators and then indicate the dimensions. Okay, so finally you are going to see in our drawing sheet like this. Clear? So it's a very simple, dear students, you practice it. This is known as a 132 kV single circuit. Similarly, let us see the double circuit also. Now you can see here, this is a double circuit. So here we have the R phase, Y phase, B phase is the right side, and R phase, Y phase, B phase is the left side. So both sides are cross arms. Okay, so now you can see. So we are going to draw this structure. Okay, so how we are going to draw this structure? So based on the dimensions. So these dimensions you should remember as a single. Now, so what is the dimensions here? So some dimensions are different. So here the length is equal to 4.5 meters. The height of the tower now in this case is nearly increased to the double structure, so 28 meters. Okay, now here this height from the up to one phase we are going to the 18 meters, and this phase to this phase I am going to use 3.7 meters, and this place to this place, that is called previously 2.6, now it is the 3.7 meters, same distance. Now this is the same 2.6 meters. Okay, so now the length between the two strings, these strings is nearly 7.8 meters. Okay, now this string, this is placed as a 8.2 meters, somewhat big, and here, so this is equal, length is equal only 6.4 meters, such a way that our engineers have designed it. So based on this dimension, this is the 4.5 meters, instead of 4 meters here I taken the 4.5 meters. So take the 4.5 meters, that is the half of this length, and take the 18 meters height, appropriately take the, here is 1 meter, 1 meter, so you draw it line. Then increase the length 3.7 meters, height, another cross arms. So length is the total length is equal to 8.2 of it, and after 3.7 you take the another cross arm, that is 6.4 total length, that is a 3.2 of it. draw the as usual. So these are the drawing you are going to draw it. Okay, clear? It's very easy, dear students. Let us see the animation. First you take the ground. So this is the tower. Length I taken the 4.5 meters, a dotted line. This the length is equal to 28 meters. Now I taken the some length here. So nearly that is equal to 18 meters plus 3.7 meters. Okay, total length I taken. Now here 18 meters I taken. So I increased the length. Okay, so here I increase the length, that is the next I close this thing, similar to the previous case. Now I am going to place the cross arms, or face, Y face, B face, double section. I placed the or face. Now at a distance, what is the distance here? So this distance is equal to 18 meters and this length is equal to nearly 7.8 meters. Okay, that means by 2, this is length, this half length, 7.8 meters total length, and the height is the 18 meters, one face, or face, for example, take the or face. Now or face to Y face, the distance is a 3.7. Okay, so you take the this face, you take, so what is the face? 3.7 meters and length, that is 8.2. So draw it 8.2. Next you take the another face and take this. Okay, so you know this thing. Now first face is over. Next Y face. So Y face is the length. What is the distance from this to this one? So 3.7 and this length is the 8.1, big one, 8.1 meters, 8.2 meters. Okay, now another face is the top one, that is the 6.4 meters. Okay, so these are the sizes. So dear students, don't confuse it. So this height is equal to 4.5 meters, this length is equal to 18 meters and this height is equal to 3.7 meters, this height is equal to 3.7 meters, this height is equal to 2.6 meters. Okay, now so this length is equal to 7.8 meters, this length is equal to 8.2 meters, this length is equal to 6.4 meters. So these are the dimensions. Simple. Draw it, indicate these dimensions on this one. Okay, is it clear? Now, so after drawing this one, you are going to appear in the drawing sheet this such a way that this is a 132 kV double circuit. Similarly, so you have to draw the 220 kV, another structure. So you can see this is a 220 kV steel tower. So voltage increased. So ground clearance has to increase. Okay, so that purpose I require the some height also increased from the fort. Okay, so this total length so maybe increased further and further. So 25, nearly 25 meters they will use for the single circuit. Okay, the double circuit further increases. This is a 220 kV single circuit. Let us draw this one. So this is a total circuit. So what to do? So here, so total length of our tower is equal to 25 meters. Okay, now this is 17 meters as usual. Okay, now this is two faces here. So we take in the nearly 2.5 meters and here also 2.5 meters and here I can use up to this one, so 3 meters I can use. Okay, so this distance, this may be, I can take here length, so 1.4 meters here I can take, this is a length is equal, I can take the 1.4 meters. Now from this place to this place I can use, they will give the 4.5 meters first R face, and here the same we are using the 4.5 meters and here same I can use the 4.5 meters. So each cross arm length is a 4.5 meters. Previously we had changed. Okay, so this is the same distance, same distance, same distance. So easy to draw this, dear students. Okay, so draw it. Now you can see the animation. First you take the ground, take the, what is the distance? That is the 6.5 meters. This one here is the 6.5 meters, not 4.5 meters. It is a 220 kV. So base require the strong. Now length you are going to write nearly the 17 meters. So complete the total structure as per the given total length, that is called 25 meters. Now so divide the place. So this place is nearly 17 meters from here to here, 17 meters. This length is equal to, from this place to this place, length is equal to 4.5 meters. Okay. Now another 4.5 meters you draw the other length. Then you are going to get this length nearly, this place is equal here to here 4.5, this is equal 2.5 meters height, and you are going to get this nearly 19.5 meters. Okay, so this is a 17 meters now. So what is this length? The same, that is the same 4.5 meters. So this is a 4.5 meters, all are 4.5 meters, this one, and a distance, this one. So nearly we are maintaining the same, that's the 2.5 meters face to face. Okay, so such a way that you draw it. Next another 2.5 meters in another face, B face. So what is the length? 4.5 meters is the horizontal length, and the height is nearly you take the 1.4 meters. So these are the total diagram, dear students. Now indicate the, after drawing this one you are going to indicate, so length, this is what is the length, indicate, that is equal 6.5 meters. Okay, then it indicates 17 meters, then indicate 4. So dear students, you can, this is length is a 1.54 meters. Okay, so you can indicate this length is equal to constant, this is a 2.5 meters, and indicate this is equal 2.5 meters, and indicates this length is the 3 meters here. Okay, now length, this indicates 4.5 meters, indicate 4.5 meters, and indicate this length also 4.5 meters. This is enough. Okay, so draw it. So you can, after drawing this one, that should be in the form of this, like this. Okay, so this is a 220 kV single circuit. Now let us do the double circuit now. So you can see this is the double circuit, 220 kV double circuit. Structure is same, but dimensions somewhat changes. Okay, so you can see the physical structure of this steel structures and distance between these conductors, strings, you can observe it. You have to draw it. Okay, so what are the dimensions for this one? So you have to remember for exam purpose. Okay, so what is the dimensions here? So here you have to take, this is the length from this port to this port, nearly that is equal 7 meters. Now so this length from ground to, so nearly that is equal 17 meters. Okay, so now this length is equal to 3.8 meters. This length is equal to same 3.8 meters, and this length, last length is equal 3.4 meters only. Okay, so this length is equal to 1.4 meters as well. Now the total length, you can see from this place to this place, horizontal length, that is equal 4.15 meters, 4.15 meters from center. Similarly here also 4.15 meters, that is 4.15 meters. Total length 8.3 meters total length. From this place to this place 8.3 meters. So off length is called 4.15 meter, 4.15 meter. So all are equal distances. From this place to this place 4.15, and this is a 4.15. This is a 4.15 and 4.15. Very easy, dear students. Okay, so you know the vertical lengths, you know the horizontal lengths. Easy to write. This is known as the 220 kV double circuits. Only dimensions changed. Now let us see the one animation. First you take the ground, take the 7 meters, say draw the one line, and take the total 28 meters one dotted line. This is the dotted line, you take is a 28 meters. Okay, now and complete the structure up to 17 meters. Take this one and place a remaining portion. Okay, then or face one side, that is a 4.15 meters at a distance from this place to this place 17 meters, and this place to this place the 4.15 meter. Similarly 4.15 meter here you are going to draw it. Okay, now take the this one circuit. Okay, so what is the distance here? It again take this is equal, what is the distance? 3.8 meters. Same length is the distance is the same distance is 4.15, 4.15. Okay, so next you take the another face. So you, dear students, you complete here. For the repeating purpose, I taken the one side first, after side I connected the second circuit. Okay, as how you are going to feel easy, you draw it. Okay, so this I placed the first R phase, Y phase, B phase. Next B phase. Okay, so now I know this, what is the length here? So length here 17 meters, from this place to 3.8 meters, from this 3.8 meters. Okay, that is 3.4 meters at top one. So here I am going to this length is a 4.1 meters, this one and this one. It's over. This one circuit is completed. Remaining this side circuit I am going to write same at the same position. Now draw it. Next R phase, Y phase, B phase. So this total circuit is completed. Okay, just after drawing this one, you indicate the this length, that is equal to 7 meters. This is equal to 17 meters. This is equal to 3.8 meters, 3.8 meters, and 3.4 meters. Okay, now length is equal to 4.1 meter for all, same 4.1, 4.15. You take the 4.15, 15. Okay, all are 15. Here also 4.15, 4.15, 4.15. So these are the total dimensions. After completion of this one with the dimensions, it looks like, yeah. Okay, so these are the 220 kV double circuit resistance. So this may be different shapes. You can see these are the another 220 kV towers. The top position, it may be changed. Okay, now you can see the another towers also instead of 220 kV. So we can see the 400 kV towers also we can observe surrounding us. So you can see this is a one 400 kV steel towers. Double strings, they are using the here string 1, string 2. Double strings are used for the conductors, maybe double conductors, quarter conductors also. Okay, but it is not in our syllabus, dear students. So we have the only this 220 kV tower only. Okay, these are the towers, dear students. Okay, so similar way you draw remaining all thing figures. Now coming to the another topic, that is the strings. Let us conclude what we have seen in this class. We have learned how to draw 132 kV single circuit and double circuit, as well as 220 kV single circuit and double circuit steel towers step by step with given standard dimensions. It is similar to draw any given towers and any voltage. It may be 400 kV or 765 kV, any tower we can draw based on given Indian electricity standards. So dear students, please complete the remaining portions. Thank you for listening my class.